go. Today we are working on 2.2. And it is direct variation. Direct variation. Now, we did this back in Algebra 1. I just want to remind you of a few things about a direct variation. Direct variation is always in the form y equals kx. Where k is our constant of variation. And to find our constant of variation is always k equals y divided by x. And the other social thing I wanted to remind you of, not just the equation and how you find k, but the very special thing about a direct variation is a direct variation graph crosses through the origin. All right, so that's the whole basics of today, but let's break it down a little bit more. Evan, I can't believe you didn't bring me any. See how you are. You should have brought me some. Oh. All right, example number 1. This is where we're going to start. You are actually going to decide if it's a direct variation from a table. So, determine if y varies directly with x. If so, state the constant of variation, or the k. All right, so if I have a table, and in my table I have my x and my y, and let's say I have let's go 2 and 14, 3 and 21, and 4 and 28. To determine if it's a direct variation, we have to do y divided by x and see if it's the same every time. Okay? So, we're going to start with the first one, our y divided by our x. So, 14 divided by 2 equals 7. In our second one here, we have 21 divided by 3 equals 7. 28 divided by 4 equals 7. So since they are all the same, doing y divided by x, this is a direct variation. Our k value equals 7, and I can write a direct variation. If I was to write the equation for this, it would be y equals 7x. That's it. So how about, let me do one more table. We're going to try this one. Let's say I have 1 and 4, 3 and 12, 5 and 20, and 6 and 27. All right, let's see if this one's a direct variation. Again, we do y over x, right? So this is 4 over 1, which equals 4. This is 12 over 3, which equals 4. 20 over 5 equals 4. 27 over 6 equals, right? It actually reduces, but it doesn't equal 4 for sure. 27 over 6 is 9 over 2, or 4.5. So since they are not all the same, this would be no, and you would stop. All right? Okay. Example number 2. Determine if the equation is a direct variation. If so, state K. All right. So this is actually what you are doing for problems 12 through 18, if you're referring back, right? Remember that for it to be a direct variation, it has to be in the form y equals kx. If it's got anything added to the end, then you say it's not. So the one important thing is we need to get y all by itself, right? So get y by itself in order to figure this out. So for example, if we have, let's say, 2x minus 3y equals 0. I got to figure out if this is a direct variation. Well, it's not in y equals kx form yet, right? So I got to move some things around. First thing I'm going to do is subtract my 2x to the other side because I'm trying to get y all by itself. So I still have a negative 3y equals negative 2x. Now what do I have to do to get y by itself? Good. Divide by the negative 3. Divide by the negative 3. So I get y equals, negative over negative is a positive, 2/3 x. Do you agree those are the same? So is this a direct variation? Is this in the form y equals kx? So this would be yes, and you would say k equals 2/3. Do you want another example of that? No? Okay. All right. Next part, back in Algebra 1, was your least favorite part. So that's why I was saving it, although it's not hard. So here are our steps for writing a direct variation and evaluating. All right, step number 1, find k. You're going to use the first 2 pieces of information to find k. Step number 2, write y equals kx. So that k you found, you're plugging it into y equals kx. Step number 3, plug in value and solve for unknown. Very easy 3 steps. So here's how it's going to look. Here's example number 3. This is exactly what you are doing for problems 20 through 26. All right. It's going to tell you y varies directly with x if y equals 4 when x equals 5, find y when x equals 7. All right, so first step says find k. We use the very first line of information right here to find k. That's all that is used for. So k equals y divided by x, or 4 divided by 5. That's my k value. Step number 2, we plug it into y equals kx. So we get y equals 4 over 5x. Right? So this was step number 1. This was step number 2. Step number 3, we use the last line. It says find y, so that's our unknown, when x equals 7. So what do you think I do? Plug 7 in. So I have y equals 4 over 5 times 7, or y equals 28 over 5. And you leave it just like that. That's step number 3. All right, so we're going to do another one just because. Okay, we're going to do another one because these are the ones that, for whatever reason, we struggle with. Again, first line information finds you k. Write it in the equation. Last line information tells you what you need to find. Okay, so let's do another one. Any questions at all before I keep going? Yeah, all right, you got this. Okay. You're welcome. Sample number 4. Y varies directly with x if y equals -3 when x equals 12. Find x when y equals 9. All right, so first step is to use the first line information to find k. K equals y divided by x, or -3 divided by 12, which reduces to -1/4. So k equals -1/4. Now we take that and we put it in our equation. Y equals -1/4 x. Now we use what we know to find the unknown. This says find x when y is 9. So I'm going to plug 9 in for y this time. So 9 goes here. 9 equals -1/4x. How do I solve this? What should I do? You can divide it. I would times it. What would you do? Times by 4 is where I'd start. Clear the fraction, right? If we times both sides by 4, we get 36 equals -x. And of course, we divide by a -1, and x equals -36. Questions on these? No questions. So we're doing okay so far? Okay. Let's see, 30 through 32 are just like the first ones with the table. I want to talk about graphing. Graphing a direct variation. When you graph a direct variation, where did I tell you it has to cross through? Yes. All right, I'm going to put it here again. Goes through 0, 0. All right. So here is example number 5. Yes? Okay. Example 5. Write and graph a direct variation through, how about the points 4, 5. All right, so first of all, if we're going to graph it, let's plot that point 4, 5. So we go 4 to the right, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. Put a dot. Now this thing has to cross through that dot and cross through the origin. So I'm going to ask you just to connect your dots. Well, that's the first part. That's graphing it. Just connect your dots. Okay? Second thing is we have to write a direct variation equation. Y equals kx. Well, how do I find k from that point? Y divided by x, right? Y is what? Divided by x, which is 4. That's it. So you'll notice, now that we have it drawn up here, we have our direct variation equation. If we start right here, if I do rise over run, I'm going to go up 5, 1, 2, 3, 4, 5, and I run over 1, 2, 3, 4. Matches our K, doesn't it? Okay? All right, let's do another one real quick. Let's say underneath the same example, it goes through the point. How about 2, -7? All right, if I were to plot 2, -7, excuse me, right there. Of course, it has to go through the origin. We connect our dots. Put little arrows on both ends. And now let's write our equation. Y equals K. What is K? Good. -7/2 x. That's it. Okay? This is what you do for 36 through 42. Doing great. Only a few more to go. 44 through 46 we've already done. So that's like the first one. I want to talk about what 48 and 50 mean. So here is example number 6. All right. Choose a value for K, then write and graph a direct variation. And it's going to give you something like this. Maybe 1 is less than K less than 3. So you just have to choose a K value between 1 and 3 somewhere. So every one of us can have something different. We can do 1.5, you can do 1.9, you can do whatever you want. Anything you want, as long as it's between 1 and 3. Most of you said 2 because that seemed easy, right? So we say K equals 2. All right. So our direct variation equation would be Y equals 2x. Graph it. Starts at the origin. That K is 2 over what? 2 over 1. So we can either plot the point 1, 2, or we can do rise over run. We can go up 2 and to the right 1. Connect our dots. Ta-da! That's it. All right. That being said, you do have, stand over here, 2 word problems. Do we need to go over how to set them up a little bit? Or let's try it and we can talk about it tomorrow. Let's try it. Sounds good. All right. So, you are on page 71 and 72, 8 through 52 even. Now, I did even because some of those answers are yes or no, right? Some of the things, I mean, how quick is it for us to do this problem? So, it's not, I know there's a few more problems than we normally would do, but they should go pretty quick. Okay? All right, so everybody get your books open.